Hey guys, it's Ron, and this is Lab 20 covering frame relay. So, a couple of quick things about frame relay. If you remember back to Lab 19, we covered HTLC and PPP. The preface behind those two technologies was that we purchased a leased line between two of our locations. So this was a point-to-point link dedicated to just us. Okay. The problem with that is, one, is it's expensive, and two, in order for me to support multiple locations, I have to buy multiple leased lines. I may not have enough ports on my router to support that, or I may just not have enough flexibility in my pocketbook to support multiple permanent virtual circuits, or permanent dedicated lines, basically. But what I can do instead is I can go the more economical route of frame relay. All right, we're still using the serial interface we did before, but instead we're going to use a packet switched technology, which means I'm competing for bandwidth. Instead of getting that dedicated bandwidth, I'm competing for some bandwidth here. However, I get it at a lot better price than I would a leased line. Okay, and now I can easily support multiple locations. Okay, so instead of a leased line, I have this thing called a permanent virtual circuit. And so I basically make a virtual circuit between one of my locations and another, and then I have another permanent virtual circuit from this location to another. So I can easily support multiple locations with one physical line. All right, because these are virtual circuits. Okay, and the way I do that is with something called the DELC, which is the data link connection identifier. Okay, so it's what's going to specify if I want to go to this location, I need to use DELC, let's say 100, and that 100 basically identifies that PVC. And if I want to go to this location, I'm going to use DELC 200, which identifies this PVC. Now, the thing about DELCs, though, is that they're only locally significant. So it's significant for me to that first frame relay switch. And this is the telco's equipment. Now, inside their frame relay network, they figure out how to map that DELC to that destination. So the DELC might change from hop to hop through here. And then also it should be different, or could be different when it finally gets to my destination. So it's only locally significant, and the telco worries about mapping that and figuring out how to get that to my destination. Also, there's something called inverse ARP. You remember in the early labs, we had ARP, which mapped our IP addresses to MAC addresses. Well, this kind of does this for DELCs. So what it's going to do is map IP addresses to DELCs. So when I try to hit an address from my router is going to use inverse ARP. It's going to reach out into the frame relay network and figure out, okay, in order to hit that IP, which DELC do I need to send it to? Okay, and it works pretty good. I won't say it works all the time. There are some cases where I'm going to actually have to just add that mapping myself. Okay, so I'm going to map in my router a specific IP to a DELC. Okay. One last thing about DELCs before we get into it is they, in and of themselves, they add a little bit of efficiency to the system. And I say that because in the Ethernet world, you remember, when I send something from one network to another network, the IP address in the packet never changes. But I might have to send the frame through multiple hops. I'm going to send it to my gateway. He's going to send it up to its next gateway, and so on and so forth until it finally gets to its destination. But at each hop, what it has to do is it has to take that packet out of the frame, look at the packet. Is this for me? No, it's not. Oh, I should send it to this gateway. So I'm going to jam it back in another frame, mark it with that next gateway's MAC address, and send it on its way. And this happens at each spot, each hop that it gets to. Well, with DELCs, that gets marked on the frame. So there's no need to extract the packet out of every one of these and rebuild the frame, re-encapsulate it and send it on its way. It just looks at the DELC and sends it along its way. So we gain some efficiencies along the way in that we're not having to rebuild that at every hop. Okay, so kind of cool. Lastly, I want to talk about LMIs, the local management interface, because this will come into play. The LMI is basically a protocol, if you will. I can't think of a better name that we use to talk to this frame relay switch. Okay, so when you sign up for service with the telco for frame relay, you're going to say, I have location X and location Y and location Z, and I want to build PVCs in between them. And the telco is going to come back and say, okay, cool. You're going to use this DELC to get to this person, and then you're going to use this LMI type to talk to my switch. Okay, so this is going to be how we talk. Okay, so they're going to specify again the DELC and the LMI type, and you're going to put that into your configuration. So I've gone ahead and defaulted my router here. So we'll wait for it to finally finish booting up, and we'll be able to get into it. So the first thing that we're going to want to do is to bring up our serial interface that we're going to be using to connect to that frame relay switch. So enable config T interface serial 01. All right, I'm going to go ahead and specify that I want to use frame relay. So encapsulation frame relay. Now here I can also specify the LMI type. So we'll do a frame relay LMI. Well, let's go back one step. Encapsulation frame relay question mark. Now there are two real versions of frame relay out here. One of them is Cisco, and one was specified by the IETF. Okay, so since I'm using all Cisco products, I leave it at the default and I don't have to specify anything. If I didn't have a Cisco router on the other end, I might have to specify IETF. Okay, in my case, Cisco's just fine. So then we'll do a frame relay. We'll do an LMI type, and I got question mark. So here we have Cisco ANSI and Q933 alpha. And again, this is going to be specified from your telco, and this is only for signaling basically how you're going to talk to that frame relay switch. Okay, so this has to be correct or you're going to be dead in the water. All right, again, I'm talking to another Cisco switch, so I could leave it at default, which is Cisco. All right, I'm going to want to go ahead and specify my IP address. And then I'm going to want to go ahead and specify the DELC that I'm going to use. All right, so I'm going to do a frame relay. We'll do an interface DLCI question mark. Okay, so now we'll be assigned from the telco a number from 16 to 1007. Okay, so in my case, I've already set it up for DELC 100. And this is basically, again, specifying in order to use this permanent virtual circuit, you're going to use DELC 100. Okay, so we'll do an end. Oh, I forgot to do a no shut on the interface. So we'll do a config T interface serial 0, 1, no shot. We weren't going to get very far if I didn't do that. All right, so we'll go do a show interface serial 0, 1. All right, so we must be still negotiating because we are up, down, meaning physically we're connected. Data link wise, we're not quite there yet, and our interface just went up, so we should be good. If you'll notice, we are encapsulation frame relay. We are LMI type Cisco and LMI Delcy 1023. Now this number I would have to look up to figure out what it actually means. I know 1023 is a good number. If it's anything other than that, you're probably not talking to that first frame relay switch, which means your LMI type might be incorrect. Okay, so 1023 is what you want to see. Now if I do a show frame relay PVC, what I'm going to see here is that for interface Delcy, or for Delcy 100, my status is active. Okay. Now, a couple things you might see here instead of active. Active means, great, everything is working the way it should be. You might also see inactive or deleted. Inactive means that I'm talking locally to my switch, to my frame relay switch, but my distant end is not talking to theirs, so the PVC can't be established. Okay, so it's inactive. Now, if you see deleted, that can mean a couple different things. It could mean I'm using the wrong Delcy number, okay? Or that Delcy was never programmed into the frame relay switch, which means I need to call the telco and figure out what's going on. Now, down here we have FECN and we have BECN, okay? Now, this is the forward explicit congestion notification. It's a mouthful. And backwards explicit congestion notification. The thing to note there is it has to do with congestion. Forward congestion means I sent data through the frame relay network. There was congestion along the way, so the telco marked the FECN bit. So when it arrives at its destination, that host knows that the data that came through met congestion. BECN is when those frame relay switches reply back to me, the sending host, and says, hey, there's congestion in the network. Okay? Now, DE goes back to that discard eligibility bit. Okay? And this is if there's congestion or not necessarily congestion in the network, but there's a time where you went above your committed information rate. And this goes back to your service level agreement. You have specified your committed information rate. You're guaranteed everything up to that committed information rate, but you're not guaranteed everything up to the access rate. Those are the rates that you can burst up to. So every time you go above that committed information rate, the DE bit gets set. And that means if we run into congestion, anything with the DE bit is fair game to be dropped. Okay? Those are the frames that are going to get dropped first. Okay? So for all intents and purposes, being active, we're good to go. So I'm going to go ahead and ping 192.168.0.2, and I'm able to ping there. Now if I do a show frame relay, and I think it's map. Let's look here. Yep, map. Just basically specifies when we tried to ping out, inverse ARP should have gone out and it mapped that IP to Delcy 100. Okay? So when we tried to hit this IP, when they were sent out, they were marked Delcy 100, and that's how it knew which permanent virtual circuit, PVC, to use along the way. Now lastly, we can do a show frame relay. I think it's LMI. Let me look here. Yep, LMI. All right, and again, we have LMI type Cisco is what we specified. Now the thing to look here is we have sent and received down here. Okay, this basically means as we're signaling the frame relay switch, we're sending that information out, or those signals out, right? And then receiving them back. So if you see a bunch of sent messages but no real received, it's a good indication, again, we're using the wrong LMI type. Okay? Now, so everything has worked, but we only set the system up to support one PVC because we used up this whole interface for that one DELC. And that's not the beauty of Frame Relay. The beauty was that we could support multiple locations, but we only had one physical link to the Frame Relay network. All right, so to do that, we need to kind of knock out what we just configured. All right, so what we're going to do is we'll do a interface serial 01, do show run interface serial 01. We're going to take out the IP address, and we're going to take out this DELC. Okay, so we'll do a no IP address, and we'll do a no. Let me copy this. Yep, missed putting a space in there. And there. Okay, so now all that has been done is Frame Relay has been set for the encapsulation. LMI type has been set to Cisco. So we'll do an exit. We'll do an interface serial 0/1. And this time we're going to specify a sub interface. And I'm just going to match it up to the same DELC number for management purposes only. Do a question mark at this point. Here we have multi-point and point-to-point. So multi-point would be in a hub-spoke network. So I have all these out sites, and for some reason, the way that I built my Frame Relay network is I wanted all of those out sites Frame Relay interface to be on the same sub-network. Okay. Now this can raise some issues with broadcasts. Frame Relay is pretty much considered a non-broadcast multi-access network, meaning that broadcasts don't always work. And the reason for that is if if I receive a broadcast in my multi-point network, typically you receive a broadcast and you send it back out to everybody, right? Well, we're all sharing that same interface. So if I send it back out, I'm violating split horizon by sending it out the same interface that I received it on. So we have some issues with broadcast, and there's some things that you can do to overcome that. We're not going to get into that in this lab because we're going to do point-to-point, meaning that I'm going to have a different sub-interface for every DELC or for every PVC that I want to support. All right, so one physical link, but now multiple sub-interfaces within that link, and all supporting different DELCs. All right, so I'm going to go ahead and specify an IP address again, 168.0.1.255.255.255.0. I'm going to specify my DELC, so Frame Relay Interface DELC 100 end. So you notice in here now, we have a sub-interface 100, and that's where our IP address is specified. So if we do a show Frame Relay PVC, had a brain fart there. We still have DELC 100 local. It is active, and now it's using that sub-interface. Okay, so we should still be able to ping our distant end. If I could type the right IP address in which we can. Show Frame Relay Map. We have now sub-interface 100 is up to point using DELC 100, and we should be good to go. Okay. Now, if I wanted to specify that second PVC, it'd be as easy, if I could type, as specifying another sub-interface. So interface serial 01 decimal 200 point-to-point, IP address 192.168.1.1, frame relay, interface, delc, we'll call this delc 200. Frame relay PVC. So we have delc 100 on serial 01 decimal 100, and we have delc 200 on serial 01 decimal 200. All right. Now, both of these are showing active, but I know this one's not going to work because I haven't set it up. Okay, that probably is matching up with the delc on my distant end and not actually the way it's supposed to be. If I go back, and you'll see config t face serial 0/1 decimal 300, and I got to do point-to-point, IP address 192.168.2.1, 255.255.255.0, frame relay, interface delc 300, show frame relay PVC. Now you'll see delc 300 in here, and my switch must be getting retarded. Oh, now it shows up. I must have just looked it up too soon, because now you'll see 200 shows deleted. And that means that this delc 200, when it's talking to my switch, isn't there. Okay? And I'm willing to bet if I run this again, yep, 300 shows as deleted as well. And that might be, again, in my case, I know it's because I don't have enough ports on my my router that I have standing in for my frame relay switch. But in the real world, this might mean that, hey, you either typed in the wrong delc number, or that delc never got programmed by your telco, and you need to give them a call. So that's pretty much it. The points that I really wanted to cover. I think the real thing to gather from this is that the delcs are locally significant. They reference the PVC, the permanent virtual circuit, that you have built to your destinations. You only have one physical interface, but through the sub-interfaces, you can support, logically, you can support multiple links. Okay? Frame relay is a packet-switched network, which means you're having to compete with other users' data. So committed information rate and access rate comes into play. And also that just inherent in frame relay, the fact that it puts those delcs on the frames, you gain some efficiencies. Those frames should make it across the network quicker than an IP routed network like Ethernet. You know, something along that line would, because it doesn't have to de-encapsulate and re-encapsulate at each hop. Okay? So I hope you gleaned something from this lab. I'll do another lab, a follow-up, to kind of show you how I built the basic switch in between. It's real easy. It's only a couple of real commands, but I'll save that for a later lab. Let me know what you thought. I hope I didn't miss anything. I'm sure I did. But thanks for watching.